Good afternoon. This is Dr. M. Ravi, uh, Assistant Professor of Chemistry. Uh, Today we discussed about the e-content of electrochemistry. Before going to discussion about the electrochemistry, let me discuss about the introduction of the electrochemistry. Look at the electrochemistry. First slide it reflects the definition of electrochemistry. Left side is the electrical energy and right side is the chemical energy. In between these two, one is the electrolysis process. By electrolysis process, which occurs in a galvanic cell. That means by using galvanic cell, electrolysis reaction converts electrical energy into chemical energy, or chemical energy into electrical energy by using electrolysis process by using galvanic cell. That's why the electrochemistry, which is the subject, which is the science, which is the chemistry, deals with the changing into energies from one energy to another energy. Simple thing is that this electrical energy converts into chemical energy by electrolysis process. The chemistry is known as the electrochemistry. Let us see next slide. Look at here. A science which deals with relationship between chemical energy and electrical energy and the rules of conversion of two energies is known as electrochemistry. And the electrochemistry is the study of the solutions of electrolytes and phenomena occurring at electrodes immersed in these solutions. That means whatever electrochemistry is that is a study of electrolytes. Electrolytes means suppose simple logic is the sodium chloride, sodium plus NaCl, sodium hydroxide, Na plus OH minus, potassium chloride, K plus Cl minus. These are the strong electrolytes. In the same manner, sodium acetate is a strong electrolyte. Acetic acid is a weak electrolyte. Ammonium hydroxide is a weak electrolyte. That means this study of the solutions is also electrochemistry. And whatever occurs in galvanic cell, zinc rod is immersed in zinc sulfate solution. Copper rod is immersed in copper sulfate solution. In both the rods, what is the reactions occur? What is the phenomena is going on at respective electrodes? The study of these electrodes, what is occurs in electrodes, is also known as a electrochemistry. Okay, let us see. This one is a electrolytes, substance whose solution in water conduct electric current. That means in water, in solution media, which allows the flow of electricity, is known as electrolyte. Conduction takes place by the movement of ions. Simple thing is that in solution media, which produces electricity by movement of ions, those are called as electrolytes. Salts, acids, bases. Salts means sodium chloride, potassium chloride, like that. Ammonium chloride. Acids means acetic acid, hydrochloric acid, sulfuric acid, like that. And bases, sodium hydroxide, potassium hydroxide. These are some of the examples of bases. Substance whose aqueous solution does not conduct electricity are called non-electrolytes. That means the substance which does not allow the current, those substances are not called as a non-electrolytes. Example: cane sugar, glucose, urea. When dissolved in glucose, some simple thing is there. Whatever glucose is there, when dissolved in water, does not undergo dissociation, does not undergo ionization. That's why it does not allow the flow of the current. That's why that is not considered as a electrolyte. The same manner, cane sugar, the same manner, urea also. Let's see types of electrolytes. Two types: strong electrolytes, weak electrolytes. Strong electrolytes means which undergoes highly ionization. Those are called as strong electrolytes. Examples: strong acids and strong bases. Weak electrolytes, those undergoes feebly ionization. Those are called as weak electrolytes. Carbonic acid, acetic acid, ammonium hydroxide. These are called as a feebly ionized electrolytes. Okay, let us discuss about the difference between electronic and electrolytic conductors. Look at their electronic conductors and electrolytic conductors are there. Flow of electricity, first one is the electronic conductors. Flow of electricity takes place without the decomposition of the substance. That means whatever electricity flow, whenever flow of electricity takes place, the substance does not undergo decomposition, does not undergo ionization. Whereas the electrolytic conductors are the flow of electricity takes place by the decomposition of the substances. Decomposition of the substance. Here only one thing is that whereas the electronic conductors, electrolytic conductors, substances does not undergo decomposition. First is the electronic, whereas the substance undergoes decomposition is called as a electrolyte conductor. And here one more point is the electronic conductors. Conduction is due to the flow of electrons. Here, flow of electricity is due to the movement of ions. Flow of electron is the electronic conductors, movement of ion is the electrolytic conductors. Whereas the conductance decreases with increase in temperature. Look at that. Electronic conductors. Conductance decreases with increase in temperature. Whereas the electrolytic conductors, conductance increases with increase in temperature. Simple logic is a electronic conductor. If we have take copper rod, just simply heat it. Simply heat it. That means heat transfer from one end to other end. After certain duration of time, that will be melts. Electron conduction will be decreases gradually, automatically stops. Whereas the electrolytic conductor, if salt will be dissolved in water, heat it continuously for 1 hour, concentration will be increases. Whenever concentration increases, automatically conduction also increases. That means electronic conductors by heating, by increasing temperature, decreases the conductance. Electrolytic conductors by increasing the temperature, increases the conductance. Okay, let us discuss about the definitions in this chapter. First one is the resistance. Resistance. Resistance refers the opposition to the flow of current, which oppose the current is known as a resistance. Which oppose the current is known as a current. Resistance, which oppose the current is a resistance. Because resistance refers to the opposition to the flow of electricity. R is directly proportional to L. L means length. R is the resistance, L is the length. R is directly proportional to 1 by A, area of cross section. Area of cross section. R is directly proportional to length. R is inversely proportional to area of cross section. From equation 1 and 2, we get the equation third one. R is the R equals to rho into 1 by L by A. Where is the rho is the proportionality constant, there is a resistivity constant or a specific constant, that is called a specific constant. R equals to rho into L by A. Okay, let us discuss about the conductance. So here the reciprocal of resistance is known as a conductance. C equals to 1 by R. C equals to 1 by R means R is the resistance. Resistance is a denominator. Due to that, that is called as a reciprocal of resistance is called as a conductance. For conductance, examples acids, bases, and salts. And simple units are the per ohms. Per ohms. R equals to ohms. Generally, resistance units are the ohms. So C equals to 1 by ohm. 1 by ohm means per ohm. If we return reverse side into remove -1 obviously OHM. OHM reverse if we return MHO, that means mho. Mho also one of the units for conductance. And Siemens. Siemens also one of the units for conductance. Insulators means which does not allow the current through it. Those are called as the insulator. In general, pure water, urea, sugar. Pure water, urea, sugar. These are the examples for conductance, non-conductances. Okay, let us discuss about this one. specific conductance. The reciprocal of specific resistance is called as a reciprocal of specific resistance is called as a specific conductance. Reciprocal of specific resistance is called as a specific conductance. K equals to 1 by K equals to 1 by conductance of unit volume of a cell is specific conductance. According to that, we get equation K equals to 1 by rho units per ohm per centimeter or per Siemens. And here, equivalent conductance. This is a conductance, the 1 gram equivalent of the electrolyte dissolved in volume in cubic centimeter of the solution. The equivalent conductance is represented by mathematically lambda equals to K into V, where lambda equals to equivalent conductivity, K equals to specific conductivity, V equals to volume of solution 1 liter, lambda equals to K into V, where V equals to 1000 by normality because of we are taking in 1 liter. That's why V equals to 1000 by normality. Simply substitute in the equation lambda equals to K into 1000 by normality. And molar conductance, a simple thing is there and here, whereas equivalent conductance and molar conductance, only one simple thing is there. Equivalent conductivity will represents with lambda, whereas a molar conductivity represents mu. Mu equals to K into V. It is the conductance of a solution containing 1 mole of the electrolyte in VCC of solution. Cc means cubic centimeter. Whereas the same, whereas the K equals to specific conductance, V equals to volume of solution. Here we have taken volume of solution in moles. That's why mu equals to K into 1000 by M. These are the units. Resistance equals to ohms, conductance equals to 1 by R equals to 1 by ohm, 1 by ohm means per ohm, reversely we should read moles. And here, units for cell constant, X equals to L by A, X equals to L by L equals to 1, A equals to centimeter square, L equals to 1 centimeter, and A equals centimeter square, centimeter cancel, automatic 1 centimeter left. So according to that one, X equals to per centimeter. So according to that one, specific conductance K equals to per centimeter per ohm, or per moles per centimeter. Whereas the equivalent conductance, whereas the normality has been taken as in gram equivalents. That's why per centimeter per ohm centimeter square gram equals. That means whatever 1000 means centimeter cube, whereas the gram equivalent. Here centimeter square, centimeter cube. Both will be cancelled. Only centimeter minus 1 will be cancelled. Only 2 left per ohms centimeter square per gram equivalent. These are the units for equivalent conductance. These are the units for molar conductance. Same per ohm per centimeter square gram molecules. Same moles per centimeter square per gram mole. These are the units for molar conductance. Electrochemical cells in general, a DNA cell examination point of view, important when initial stage. That means starting of this chapter, we discussed about the electrochemistry, which deals about the solutions, electrolytes along with the immersed substances. Immersed substance, zinc rod is immersed in zinc sulfate, copper rod is immersed in copper sulfate. What happens is observed in second diagram. Zinc rod is immersed in zinc sulfate solution. That means we start the study of the solution and electrode. The study of the solution and what happens in electrode that will be discussed in this chapter, that is known as electrochemistry. Here zinc rod is dipped in zinc sulfate solution, copper rod is dipped in copper sulfate solution, zinc becomes to zinc plus 2, copper becomes to copper plus 2 to copper. That means zinc undergoes oxidation, copper undergoes to reduction. By using oxidation reduction, we have to write the write the nullified equation or equivalent total equation zinc plus copper plus 2 gives us zinc plus 2 plus copper. Okay, let us see this one is the one more Danielson diagram. Cell notation is not in your syllabus. Salt bridge is not in your syllabus. Nernst equation. Yes, Nernst equation. Look at that. E equals to E naught plus 2.303 or T divided by NF log reactants concentration divided by product concentration. Look at how we can derive this equation. First, look at there. A plus capital A, small a, capital A plus small b, capital B gives rise to small l, capital L plus small m, capital. Applying Van Derf equation, both the equation for above chemical reaction, we get the equation E equals to E naught minus RT divided by NF log products concentrations and reactant concentration. If minus becomes to plus means automatically reactants becomes to products, product becomes to reactants. E equals to E naught RT NF log reactants concentrations by product concentrations. And finally we get the equation E equals to E naught minus 2.303 RT divided by NF log reactants concentration and product concentration. Whereas R equals to gas is constant, kilojoules per mole, and F equals to Fahrenheit, T equals to absolute temperature 298 degrees to 298 Kelvin. We get finally this equation equals to E naught plus RT divided by N 2.303 log products concentration by reactants. That means ionic state divided by molecular state. This is also one more different form of the Nernst equation. Electrical series, electromotive series. Look at there, electromotive series. First is the first column shows electrode, second column shows electrode reaction, third column shows EMF value. Look at there, E naught value, whatever electromotive force value gradually negative becomes to zero. After crossing zero, that becomes to positive. That means in increasing order of electromotive values is known as the electromotive series. Increasing strength of the electromotive forces is called as a electromotive series. As initially lithium plus becomes to lithium, that is a minus 3.00 volts, minus 3.01 volts, whereas the hydrogen H plus converts into H2 gas 0.00 volts, whereas the fluorine F2 converts into F minus. That means plus 2. That means increasing electromotive force is known as a electromotive series. These are the different types of the all metals electromotive series, electrochemical series of different metals. Applications of the electrochemical series. This gives the information about the oxidation and reduction, which gives the information about the oxidation and reduction, that is known as one of the application of the electrochemical series. And electrochemical series give one more information about the tendencies of the metals. Tendencies of the metal means that is a negative charge or positive charge. It gains electrons, it lose electrons. That is known as the tendency information of the metal. And one more point is that information about the relative corrosion. Corrosion about regarding about the corrosion also that will give information. Corrosion means it will be undergoes oxidation or reduction by oxygen by reaction with oxygen if that might be chance to undergo corrosion property also. That's why that will give the very important information about the corrosion also and predicts spontaneity of redox reactions. That means that will give information about the redox reactions. Types of electrodes. These are the four different types of electrodes are there. Type 1, type 2, type 3, and 4. The type 1 is reversible with respect to the electrode materials. In type 1, again divided to three different types of materials, electrodes. One is a metal ion electrode, zinc electrode example, gas electrodes, hydrogen electrode example, amalgam electrodes, cadmium electrode example. And, second type of electrode, type 2, secondary reference electrodes, calomel electrode in general. Third type of electrodes, an electrode consists of the metal, one of its insoluble salts. These electrodes are reversible with respect to cation. These are the type 3 examples. Look at there, lead oxalate converts into calcium oxalate. That means lead plus 2 converts into lead. That means plus 2 becomes to 0. Whereas the fourth category, twin hydrogen electrode. Twin hydrogen electrode. And here in your syllabus, calomel electrode and the glass electrode is there. Let us discuss about the calomel electrode. This is the construction of calomel electrode. It consists of mercury in contact with potassium chloride solution with mercurous chloride, Hg2Cl. The potential of the electrode depends upon the concentration of the electrolyte. Whether anode, cathode, anode half cell mercury liquid converts into mercury plus, that means Hg2Cl2 solid KCl. At cathode half cell KCl Hg plus 2 comes to Hg. The total overall cell reaction. One more electrode is there, that is the glass electrode, aluminum electrode, then after glass electrode. But there the construction and function of electrodes. Glass electrode in the syllabus clearly mentioned, like aluminum electrode and glass electrode. This glass electrode is made of a special soda silicate glass with high electrical conductivity. The thin glass bulb remains filled with 0.1 HCl and silver wire coated with silver chloride is kept immersed. That means whatever made it glass is called as a special soda glass, special soda silicate glass. This is a very thin glass. Well, bottom side of the glass is one small bulb is there. That is filled with 0.1 HCl and the silver wire is coated and that is immersed with the silver solid silver. Solid silver, solid silver. Whereas here, overall reaction glass electrode, the electrode can be represented as a Ag comes to Ag chloride, 0.1 HCl. This should be useful to determine the concentration of the pH of the respective solutions. This is an experimental application. This is one of the application, but in your syllabus not here. This is not inserted in your syllabus. Okay, let us discuss about the batteries. Batteries are the two types: primary batteries and secondary batteries. Look at their primary batteries, the lithium batteries. Primary lithium battery classified on the basis of the electrolyte and solvent and the material of cathode. Their primary lithium battery and which is a secondary lithium battery. Both are applicable in nowadays mobile phones also. These are the overall cell reactions. Lead acid battery, and finally, these batteries are also applicable in wrist watches also, and mobile watches cells, whatever nowadays applicable general life, general life. Thank you.